Hey guys, welcome to my beginner Python tutorials. I'm going to try to keep the videos between 5 and 15 minutes because I want to get straight to the point, explain what it is exactly that you can expect from the topic that I'm going over, and then just go kind of experiment on your own. I don't want to get too crazy with like underlying mechanics of how it may or may not work, just because that could be a little too in depth for just kind of getting into programming initially. And I think if you can just kind of know what things do versus why things are, it'll be much more functional as you start. When you are a little bit more experienced with it, then you can start going into the whys, and then it'll really like push your understanding of the language further. This video is about threads. There's a lot of things that can go wrong if you're trying to implement threads in your code, but if you're just trying to do some basic stuff with them, they will generally only make it better. There's a couple things to note. If your script or program is CPU bound, as in you're pretty much using all of the CPU already, adding threads is not going to make it perform any better. What it could do, though, in this case, is allow you to run multiple different pieces of code concurrently or at the same time, pretty much. Not for performance gains, but for just because you have extra things that need to go on and you need to keep track of multiple things at one time instead of just, blocking one thing. The other example would be if it's not CPU bound, it's something maybe over the network. And you'll see performance improvement for sure because you're waiting on the server to respond. So instead of waiting for the server to respond, let's say 10 times, I can connect all 10 at once, wait for the server to respond, and you'd theoretically be 10 times faster. So things like that are where you'll see the performance gains. What I have in this file is a lot of the same stuff over and over again, but just different ways to put it. I want to kind of show the basics of threading and then get a little bit more advanced, but not too crazy to where you have to worry about anything. So the first two things we have are just identical functions with different names, and all they're doing is starting a while loop, and they'll never end, right? I pick a random number between 0 and 4, and then I wait for that long, print the thread, and continue, right? So nothing crazy about that. But because it's a while true, we know that it's blocking forever. If I don't break out of that, it will stay there. No other code can continue to execute. With threads, it's going to bypass that. It's going to call up that in a thread, which will allow the main process to continue. And in this case, I'm going to be calling thread 1 and thread 2, and that's it. And then what I have actually here is another while true where I'm doing nothing to prevent the rest of the code from running. So as I move down the code, I'm going to get rid of that too so I can show you the next examples. Because it would go and literally process the entire file since they're all doing something with threads. So let me run this so you can see what's going on. So it might not look very apparent that these are running side by side because you're kind of just seeing 1, 2, 1, 2, 1, 2, but in some cases you do see multiples of the same number. And really what we're getting at here is the fact that you have two while loops running side by side, and normally you wouldn't be able to do that. So that's what the threading is achieving here. This is part of it would be CPU bound. I'm not going to really get any performance improvements necessarily doing this, but I might want two things to be going, right? So in this example, I am explicitly calling, and this is the syntax for thread, function thread 1 with argument 1 and function thread 2 with argument 2, right? That's what happened. Now, the interesting thing about this, and you might have already noticed, those two functions are identical. The only thing that's different is the name. So instead of writing the function twice, I could have just wrote the function once and instead just changed the argument that I'm sending in. So in this next one, I'm doing the same exact thing. I'm calling two threads, but I'm just calling the same function twice. And this is where, you know, you'll start seeing it get a little bit more clear where the power of threads and threading comes in. You're reusing code and you're doing a lot of things at the same time. So let me comment this out. I'm just going to show you it's pretty much exactly the same as the one before. You won't even notice a difference. Alright, I'm going to cut that short. We don't need to see any more of that. So there's not much to add to that other than if you're going to be doing the same task, write one function and just call many threads. I'm going to explain a little bit more how to do that going forward because, of course, the way these are set, I'm explicitly calling each thread, and that's not very nice because maybe I want to do a different amount of threads depending on the computer I'm running it on or the job that I'm doing or whatever the case may be. So a better way to run threads is actually to be a little bit more dynamic with it. Have an actual thread count, and then we'll start that many threads for whatever was configured, right? So here I have, let me comment this out. So here I just set thread count equal to 10. But what I could do is make thread count equal to some user input. The user says how many threads they want to do from this script, and then it'll suck that up and it'll iterate over the range of the thread count and make a thread for that. And this works exactly the same as the others. Threads don't block, so I just keep calling a thread over and over again. And just to show, you know, in the same light as the other ones, I have I becoming the value of the numbers going up, and then that's what I'm going to be printing. So when I print this, you'll just see the same thing, but just 10 times with a little bit more of a dynamic approach to it. And while we're here, I guess it's good to note that if you look closely, you'll see that they all started in order because, of course, right, we're going down a list in order doing it. So the first time you start them, it's going to go bloop in order, and then whatever happens, right? They're going to be processing their own stuff, doing their own thing. It's, you know, anything goes at that point. So what can be a little bit crazy about threads is the fact that since they don't block, if I didn't have this while true here, it would just keep running the next code, right? Well, that could be a problem because maybe I want to wait for something that's running some threads to stop before I continue some code. So I need to tell it, hey, wait until these threads finish, and then you can go ahead and continue. So this next example is doing exactly that. What I'm doing here is I'm going back a little bit to how the first example was, except I am assigning the threading to a variable here, and instead of putting the dot start at the end, I'm doing the variable dot start, and here's the command that matters, the join. Join, I don't know why they call it join, I haven't really ever cared to look into it, but join is what is telling that to wait for that thread. And in this particular case, I'm starting one thread, I'm telling it to wait for it to finish, and then I'm calling another thread. Well, because I'm telling it to wait, the second thread's never going to start. So in this example, we're only going to see thread 1 keep processing. And of course, you really wouldn't want to do this. If you call one thread, wait for it to finish, and then call another thread, you're essentially just running your program sequentially in order. You can just get rid of the threads. You don't need them. But this is an example to kind of get us towards where we want to go for doing this with many threads. So let me print this out just so you could see. All right, there we go. So the next part is now taking the joining or waiting and the dynamicness of it and putting them both together, right? And then having it do its thing. So before I go into this part right here, I want to explain that putting the join inside would be a problem. Once you start a thread, if I tell it to wait, it will never process the other threads. So this right now, as is, would actually be the same thing as before. It would start the first thread, and then it would just say wait, and then the other 9 wouldn't start at all. So I'm going to show that just being a problem. What we want to do is we want to start all the threads, and then we can tell the system to wait for them to finish. And the way we're doing that is when we start the thread, we're doing it just like before, but we're taking the object or the variable assignment, right? And we're appending it to a list. And that variable is holding a reference to what that thread is. So every time I start a thread, I take it and I put it in this list. And then once all the threads are started, I can go back through that list, normal iterating, and do a join on it. That was tabbed over one extra. So what this is going to do is start all the threads first and then tell them to wait. And so I have a little print statement right here. You won't see this print statement, but this could really be anything, right? It's just anything that's going to happen after these threads finish. But since my threads don't finish, it won't print. So there we go. Now, I guess in many cases, so it depends on how you would want to do this, right? I very rarely in my own code tell the threads to wait because I'm either writing a script that just goes and does something real fast and then that's it, or I'm writing applications that if I'm using threads, it's because I'm doing multiple things and they're always going. A thread, when it finishes, will stop. It will tear itself down. So the problem isn't getting rid of the thread once it's done, right? It's because this, whatever you're doing in these threads needs to finish before you continue on, which almost defeats the purpose of threads. It's kind of weird, right? So that's why I don't really use it. I'm sure there's plenty of cases you would want to do that. I just really don't, because I'm either using threads that are never going to end, or I'm doing something that I don't care if it finishes first or second or whatever, you know? So what I'm going to do real quick is I'm just going to get rid of this join again, and just change this to the next one. And I just want to show you again so you could see I'm going to run all the threads, but I'm going to still see I'm seen. So if I had any code here, it would keep going. So all those threads, even though they're never going to end, I still have a whole bunch of stuff I can do in this main, thread. So right when all of them went, I am seen. And then, of course, you'll never see that again, right? Because it did its thing and the other ones are still doing their thing. And if you had I am seen in a loop or something else or more stuff come in, they would happen. The code is technically stuck on a while true. The code could just end and not go anywhere. And then once the threads are done, the code will be finished. So there's a lot of different ways you can order this stuff. and you could decide what you're going to put in a thread, what you're going to leave in the main one. I don't really think it matters too much as long as the thing does what you want it to do. And at, entry level stages, I mean, you're not doing anything too crazy anyway, just kind of make it work. So the last little piece here, I just want to show an example, like a real world example of how you could use a thread. And one of the things that I do is I have a timer, and it depends on what I'm doing with this timer. But in this case, I am preventing something from continuing until a time has passed. So something that this could be used for is ensuring that when you're logging into a server somewhere, that people can't do timing attacks on you, because you're guaranteeing that every time someone tries to log in, it takes the same amount of time, right? As long as your waiting is taking longer than the longest time it would take. So if you just pick a time longer, in this case, I'm just picking 3 seconds. So I'm using a class in this example. Don't get caught up in that. It's just gonna let me share variables, but I will have another video about classes. So basically what I'm doing is I'm calling this function right here. This function is starting a thread, which is the timer, and then it's starting or calling do something. And what do something is going to do is just log the, or take a variable of the time right when it starts, get itself in a while loop, print over and over again, and every time it prints, it's going to check if the timer's expired. Once the timer expires, it's going to break, and then it will take the end time and then print the result, basically the elapsed time. So the timer, of course, is just when it gets called, it sets expired to false, waits 3 seconds, and then it sets expired to true. So I'm going to run this, and basically what you're going to see is the do something is going to finish just after 3 seconds. There we go. And I can make this number whatever, because printing something literally takes, like 0.001 milliseconds. So I can even make this, 0.5 seconds, and it would have, basically the same thing. So of course, this doing some function could be whatever you want. Once it's finished, it's going to just keep checking to see if the timer's expired. And once it is, it continues on. And I can even have more code after the break to go keep doing something. In the case of my example of the logging in, once the timer expires, I will return the result back to the user, whether they logged in or not. Because I don't care if it was successful or not. I want to hold on to it so they don't know based off of the time whether a user account was in there or not. Anyways, that's it for this. If you guys have any questions about anything specific, feel free to ask and I'll try to answer. But I'll have a more detailed video about threads and threading and thread safe and all that stuff in a more advanced video. If you like the video, please like and subscribe. It'll let me know whether I should be making more of this stuff or not. Also, in the description, I'll have some links to things like my Twitch channel where I program live, as well as do network security stuff, pen testing, things like that. My notify.me, and any information related to like the operating system I use, text editor, and all that good stuff. Take it easy.